Okay, and we are ready to begin. So, obviously no quiz today, because starting the next time we have class on Monday, we'll start with quizzes again. I wanted to kind of have sort of the last installment, hopefully it's going to be the last installment of our little speeches, our little heart-to-heart, and I just want to make sure that we fully understand the situation, we fully understand each other, we fully understand the reality in which we find ourselves. So, the first time I spoke to you guys, I spoke to you about how to study, very general principles. I spoke with like 4 people today where I gave them like specific instruction. Okay, from 12 to 2, you're doing this. From 3 to 5, you're doing that. I did that with a bunch of people and I got specific. But this is a more general, for the general audience. So I told you guys how to study, what you should pay attention to, all that. I also gave you a speech about the mindset that you want to have with studying, about the importance of setting goals, being specific, putting a time limit, having a way to assess whether you're on track to meet that goal, and the importance of when that assessment tells you that you're not meeting that goal, the fact that you need to put a plan into action to actually course correct so that you're back on target. Now I wanted to talk about what to kind of expect when that happens, because a lot of people don't really know what to expect, and that again causes them to give up prematurely. So, a lot of people have a lot of opinions about me. I've been teaching for over 10 years, so I've seen a lot of students, and a lot of people tell you different things about Javon. Okay? Here's something that I can say for sure. If someone tells you, Javon's the man, I followed his advice, and in like a week, everything was on target. I was on top of things, and it was just like this, like night and day. I followed his advice, and yeah, man, you better listen to Javon. Take his class, man. He's the man. Javon's the man. I can promise you that person did not follow my advice. That's for sure. You see, the person who actually follows my advice is going to be cursing me. That person is going to be frustrated. That person is going to be angry. At least for a little while. You see, improving yourself, going from a point where, okay, here's something that I'm unable to do right now, to a point where, okay, now I'm able to do this. One thing you have to realize is that path necessarily involves discomfort. If you feel like you're studying and everything's going great, and yeah, man, you're not improving. I don't care what you're doing, I don't care how much time you're spending, I don't care how you feel like everything's going great, it's not going great. See, when things start going great, contrary to popular belief, it doesn't feel like it's going great. A lot of times it gets worse before it gets better, right? One way in which you know if you're following my advice is it's going to feel uncomfortable, right? Now, I want you guys to be prepared for that. A lot of people kind of think, let's say, here you are, right? You, or current you, let's call that. I know, first of all, a lot of people think of themselves as this stagnant thing, I'm this kind of person. You're always changing, all the time, right? A lot of people have a fixed mindset, and they'll tell themselves, oh, I'm just not good at math, and that's the reality, that's how it is, and I can never get better. Right? That's called having a fixed mindset. There's overwhelming evidence that you're wrong if you have that belief. And if you have that belief, it's probably a little bit deeper to correct it than I could explain to you in 3 speeches directed at a general audience. That's probably something you want to get professional help about. If you have a deep-seated belief that I've always been bad at math, I'll always be bad at math, I'm just not a math person, you need to talk to someone about that. Figure out why you have that belief, because it's wrong, for sure. Now, I'm talking to the people who assume they have the belief that they can get better, right? And you might not even be in a great situation. You might be down here. You got 40 on test 1. That's it's definitely an F. That's solid in the F territory. And that's you right now, right? The mistake is thinking that that's your destiny, that, oh, I failed test 1, it's kind of over. You don't want to have that point of view. You want to have what we call a growth mindset, saying, okay, that's where I am right now, but it is possible for me to do better. And sometimes it will seem crazy, right? Because I wrote down the goals on the board over there last time, and I was like, okay, here's the goal that I want for the class. Everyone should be aiming at a 94. And I heard some of the reactions in the crowd. Ha! 94! Ha! Funny, Javon. Yeah, I was serious. Every single person should be aiming for a 94. And I'm also serious, and I'm 100% certain of this, it is attainable for every single person, right? Because I have seen, in my over a decade of teaching and tutoring, I have seen people improve in really radical ways. People who, when they came to me, they thought they never had a hope, right? I know it's possible. You first need to start believing that, and that's not really something like my speech right now can help you with. That's something that's going to be a very personal journey. But when I told you guys to aim for an A, aim for a minimum of 94, to some of you it might seem so far away, so above your level. This is like you with a 94. That's what, I can hardly even see that. Are you kidding me? Right? I'm way down here. You want me to get up there, all the way over there? I'm like, yes, that's where I want you to get. And I know it's possible for you to get there. Now, here's a problem. Let's say you buy into the hype. You believe what I'm saying. I'm like, yeah, I can definitely improve. There is a potential issue that you guys can hit that I want to preemptively get that out of the way so you don't fall into that trap. You see, you might think that what it's going to look like is, okay, be a little rough getting this, this Javon's thing into action, with the plan he gave me. But after that, it's going to be a straight shot. And we think that's what success looks like. Kind of like a straight shot. You see, this is, I don't know if this is showing up. This is a little bit of a darker red than I normally have. Right? So a lot of people think that's what success is like. This is the expectation. Oh yeah, do this 10 minutes a day. Expectation. Right? So that's what people think of success. This is the expectation. All I have to do is just, put in a little work here and there, just kind of set up my schedule, tell people that, I gotta be studying, learn the definitions, learn what's going on, and yeah, off to the races, right? And that's the expectation. The reality is not the same. The reality is not like that. You see, the reality is, you have to understand the current you is a product of years of decision making in a certain way, right? It's years of studying habits, years of looking at math a certain way, years of looking at whatever a certain way that brought you to the current you. Meaning, that current you is isolated by whether or not you like your current situation. I can tell you for sure, it's isolated with somewhat of a comfort zone. This is what I'm comfortable with believing. This is, now you won't see it as being comfortable. You'd be like, oh, I'm bad at math. But once you say, oh, that's kind of where I am, this is the person who I am, I'm bad at math, what that is, that means you've made your peace with it. And you've had a little protected little self-identity right here. You have this little comfort zone, right? Now, of course, to get to where you want to get to is obviously outside of the comfort zone. It's obviously going against all the decisions you've been making in your life up to this point. By necessity, that will not be a comfortable journey. It's not going to be comfortable. You're literally going to have to do things uncomfortable to make it, right? And that's the misunderstanding. You see, success doesn't really look like this, like a straight shot. Oh yeah, just put these in place and I'm off to the races. No, if you really want to make an improvement, if you really want to improve yourself, become a better version, the journey is going to look more like this. So let me try a different color chalk here. It's expectation versus the reality. See, normally you were comfortable just doing your little homework, you tried a couple of times and you finally got through the homework problems and you tell yourself, oh, I understand. And then you go to class and blah, 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 and oh, I understood what Javon did in today's class, and you tell yourself you understand. Now, when you try to do things to the standard that I'm getting you to do them, you are not allowed to tell yourself you understand unless you can do a bunch of problems by yourself, hitting a 94 in every single problem set routinely. You see, when you start doing that, you're going to realize that you don't understand. And your ego is going to take a hit, first of all. You're going to immediately lose some self-confidence. You're going to immediately have a slowdown in productivity. See, before, you spent an hour on homework and you thought you were fine. Now you're going to realize, you know what? It actually takes me an additional 3 hours to actually get to a point where, according to the rules that Javon gave me, I know I understand. Going to take more time, more hard work, more effort, more decision making in a way that you are not used to making decisions. You are immediately going to take a hit. You're immediately going to realize your study sessions went from 1 hour to 2 hours to 3 hours. You're immediately going to have things, you're going to be doing things that you're not used to doing. That comes with a price. You're going to take a hit. Now, why I need to tell you this is because a lot of the times when people take that hit, give up. It's obviously not working. What are you talking about? I'm following your advice. I used to get, it wasn't great, but I got 6 out of 10s on quizzes before. Now I'm taking extra time, I'm sleeping less. Now I'm getting 4 out of 10 on the quizzes. It's obviously not working. Let me give up and go back to the way it used to be. Let me do what I used to do in high school, because I was awesome at math in high school. And so a lot of people give up on the path because there's this dip, and they tell themselves it's not working. But it takes some time for you to adapt, and you can adapt. As a human being, I told you this once, it's your superpower, adapting. It will take some time. There will be a dip. It's going to feel frustrating. You're going to feel like, I'm working like 10 times as hard, and if my grades are improving, they're not improving by 10 times. It's improving by a little bit. It's going to take some time. And when you hit that dip, a lot of people are going to immediately say, something is wrong. I'm getting farther away from the 94 than I used to be. That's normal, completely normal. When that happens, I don't want you guys to panic, right? So you need to realize sometimes you can, you can look at I don't know if the camera, you can look at the objective. Let's say, getting an A in 90, an A in 195 is like, moving this chair from here to here, right? That's the analogy, right? Now, what you've been doing up until this time, and what you realize what the test has probably revealed to you, is that what you've actually been doing is this. Trying to push it over there, and you're like, yeah, doing great. But you're not keeping track of where you actually are. You're not any closer to the target. You're doing something, but it's not actually making a difference. And the thing is, it takes the test for you to realize, oh, what I was doing is actually not making any difference. The test is going to come and be like, no, dude, the chair is still right there. And so now, I'm going to tell you, oh, you need to do this thing, this is how you're going to change, this is how you're going to change. And you're like, yeah, okay, and you believe me, and you're like, okay, all right, yeah. And the thing is, most people expect the chair to go right there after that initial push. And then they're like, all this new effort to just move these 3 inches, are you kidding me? Forget this, forget this. I'll just go back to high school, I'll do things the old way. I go back to my old way of making decisions, forgetting that that's why you're here in the first place. If going back to the old way was so great, you would not have been here. So what happens when you push it and it only moves 3 inches? Well, if you have a goal, you know that you have to get there. You have a very compelling reason to get there. What is the option to do now? Push harder. You don't give up. That's the total opposite. I need to get this chair right there. Here's the reason why I need to get this chair right there. If I do this and it only moves 3 inches, I'm not going to give up. I'm going to push harder. Okay, now we're starting to make something. And that's going to start happening. You need to push through. A lot of people do completely the opposite of what they're doing, right? Kind of like in the same way that they have problems with math where they're expanding when they should be factoring. Yeah, that's kind of what people do here. They give up when they should be doing completely the opposite. They should be pushing harder. They should be studying longer. They should be studying more in depth than they were. They should probably be recopying their notes instead of just reading over their notes. They need to be doing more. They need to be giving it a harder push. But a lot of people, once they realize, it doesn't feel great, this kind of sucks, it's uncomfortable, my grades aren't really budging, they give up. No, you need to get the chair across the room. At all costs, you need to understand that was the goal. There's a very important reason to meet that goal. If I try something and the goal is not achieved, I try something else and I try harder. Not less, not give up. You try harder. Right? You might even be trying to do what I'm doing and you're not hitting the 94s. Man, I'm redoing this problem, I'm going to tutoring like you said, the highest grade I've gotten on these things are 75s. Push harder. That's what you're supposed to do. You're not supposed to give up. Push harder. Because you need to make the chair go all the way to the end. And so now you're going to be like, alright, okay, all right. So here's where you should be on track, right? This is the 94. Kind of the place where people expect to be overnight, right? Okay, we're getting it, okay, yeah, I think I can do this. Boom. Damn, man, Javon really killed me with that new quiz number 10. Got a 3 out of 10. Damn, what happened? I thought everything was going so great. Forget this, man. A lot of people would give up here again, right? Right? So they're like here, and they're like, yeah, okay, this seems to be going right. Okay, a quiz comes, boom! What the hell just happened? Okay. Now there could be a multitude of reasons why this happens. I don't know what could be, but you can be like, okay, all right, shake it up, all right. I have to get the chair over there. This is the reason why I need to do it. Let's keep going. Let's do it again. All right. Try to do harder. If you're smart, you probably, at this point, maybe get some advice, kind of figure out what's happening. I thought my studying was going well. I was hitting grades closer to a 94, and then, I don't know, that last quiz he gave me, it threw me. Where did I go wrong? What could I do better? You need to figure out what was happening. And then you might, okay, now you fill in some more gaps. You're now a stronger person, more understanding of yourself as well as the course. And yeah, right, going up. All right, you're like, yeah, all right, next quiz, I'm gonna kill the quiz, man. Okay, you're heading up here, and then it's like, boom! What happened now? Well, I had like 3 quizzes on the same day. Do these professors like come together and decide to put all the tests on the same day or on the same week? Is this a conspiracy? Right? So you like test, like you have multiple quizzes on the same day or whatever. Right? So I'm just giving examples of things that can happen because life is unpredictable and it's going to throw things in your way that you never planned for, that you never expected. Well, do we give up now? No. I have to get there. At all costs, I have to get there. It's important for me to be there. So no, I'm not going to give up now. Okay. Okay, let's try. Okay, let's try to study even harder so that if I have 2 tests on the same day, okay, I can actually make it now. Okay, so you're kind of go, got a cold. Okay, lost 3 days of studying. All right, gotta get back into it. Okay, okay, all right, going back. Okay, all right, I'm getting back into the groove. Boom. now my mom got sick, I have to be with her in the hospital, or my brother got in trouble with the law, I gotta go bail him out, I gotta do something. You know, something's gonna happen. And you're gonna go off the deep end again. And then you're gonna have to remind yourself, why am I doing this? Where do I want to be? I want to be there. Why do I want to be there? For this reason. This is very important. Okay, let's do this again. All right? Now the thing is, you'll recover a lot faster because a lot of learning and new experiences happen here. So you'll tend to, even if you take a major hit, you'll actually recover from that hit a lot faster, which is what most people don't realize. Right? It took them so much work to get here, and then they give up, not realizing that you're actually stronger now, right? You are going to actually be able to climb a lot faster over time. Sure, you employ new study habits, you're just not used to them. Eventually you'll get faster, you'll get more efficient. You'll learn about yourself, you'll understand, okay, me doing flashcards didn't work, me rewatching YouTube videos worked. Or maybe this didn't work and that worked. You're gaining new experience this whole time you're struggling, right? So you'll actually be able to recover a lot faster, right? Most people never get to the point where they realize that they can do that, right? They just think, oh, it's always going to be like a major struggle. No. You will learn things that will help you to recover faster. And you're going to, okay, let's go again. All right, you're back up here in no time, right? Then you're, okay, all right, I'm almost going to hit it. What's wrong, man? Girlfriend broke up with me, man. That's 8 years relationship. I gave that relationship 110%. How is she gonna do me like that, yo? And at this point, you're like, man, I don't even want to do anything. Just go and just moping, you're eating your Haagen-Dazs, and I'm not doing this. Then give you another quiz and I'm like, what's up? I thought you were improving. And you're like, yo, Javon, man, things just aren't going well. I'll just take the F and I'll try again next semester, I guess. Oh, but I thought don't you have a reason why you want to do this? Oh yeah. This is the reason why right here. It's more important than my current relationship status. I can deal with that in 6 weeks' time, right? Let her cool off, I'll figure something out. Okay, it's very important that I get back on track. Okay, you're going, okay, you're improving a lot faster, you're right, you hit the books, okay, we're almost there. Oh, what the hell happened now? Poorest finals week. Right? Jeez, I got 3 finals. I have 3 finals back to back. And then just one day in between them and I have another final. How do people even do this? Man, I'm hardly getting any sleep, right? I'm pretty sure my blood type is caffeine by now. I don't know. But still, I think I learned enough. I think, I'll just push a little bit harder and I guess I could get a B+. I mean, coming from a 40, a B+ would be awesome. I could push a little bit harder, maybe get to like here, end the semester with a B+, pretty respectable. Yeah, B+ is fine. B+ is, I think, yeah, I'll just, split my time, probably get some more sleep. A B+ is fine. But you see, a B+ is not fine. Because you set a goal of a 94. A 94 doesn't get you a B+. Now you might say, well, what's the harm of stopping now? Well, for one, you would not have gained success. Now that is going to be, it's going to take a while for people to be convinced of this, but I can tell you now, what you are actually forming is a new comfort zone. See, now that is going to bring you down the path of a new comfort zone of almost achieving the goal, and that's good enough. And you know what? If you stop there, that's going to be your life. Always, it's good enough. Yeah, I could be a little bit more comfortable, but I'm fine with this. I'm a lot better than I used to be, you know, so it's good enough. It is not good enough. You set a goal, and not achieving that goal is going to now give you another, it's going to put something else in your character. It's going to convince you of something else about yourself. Now, whether or not that happens consciously or unconsciously, it doesn't matter. It's going to happen. You are now going to form a new idea of yourself as, I'm good enough. I'm I. See, I people don't get the success that they want. I people always want something a little bit more. Why get a B if you could get an A? Why would you do that? You know what? I could get $1 million. I'll settle for 500,000. Why? Why? How does that make sense? You set a goal. You have to have a very compelling reason that not only is going to push you from the brink of failure, but it's going to push you from good enough. See, good is the enemy of great. We're not about good enough. We're about achieving the goal. You need to come up with a new narrative about yourself. You need to come up with, I'm not the person just no good and I'll always be no good. I'm also not the person who's going to settle for good enough. I'm the person that when I set a goal, that goal is achieved. Is it possible for me to get a 94? Yeah. Millions of kids have gotten A's in pre-calc before me. It's definitely possible. They're not smarter than me. You see, it all comes down to not your intelligence, which a lot of people kind of think that's what it's all about. I'm not smart enough. Irrelevant. What it takes to get to a goal is that you have to pay the price. And the price for success looks like this. It doesn't look like that. Now, a lot of you might have various reasons why you believe that success would look like that. And maybe it's because, you know, maybe the people that you look up to will tell you that, yeah, I'm killing it every day. You know, you see at these points here, see, that's where the Instagram post usually shows up. Yeah, I'm here killing it, man. Yeah, work hard, I'm hustling, baby. Yeah, they show you this. So you're like, yeah, that's okay. Okay, that's what it's supposed to look like. It's not looking like that. They're not posting pictures of them sobbing over the fact that their girlfriend dumped them, or them sitting in a hospital with their mom, you know, or whatever, right? What you're seeing when you look at success, it's not the full picture. People always see the peaks. They're not going to see you when you're at home, it's 2 a.m., you're trying the same problem over 10 times, and you're not getting the answer. People don't see that, right? People see you here, when Javon asks a question in class and you raise your hand and you know the answer. And then everyone looks at you like, oh, that person must be smart, they're just a math person. They don't know, I studied for 6 hours to be able to answer that question. They don't see that. They see you raising your hand and answering the question, right? People don't see this. And I can tell you, as a teacher, I see this all the time. Those people who you think, there was a time when I used to collect homework, like actually written homework. And you know one thing I noticed about the smart students, the students who, you know, are just good math people? They were doing at least twice the amount of work that everyone else was doing. But see, no one else sees that. See, I give a bunch of problems. Hey, do the odd problems for homework. See the people who are getting the A's and the B's? They do the odds and the evens. They give me double the homework as everybody else. And that was a regular occurrence. They're the ones who are emailing me at very odd hours of the night, oh, I was trying this problem, it didn't happen. They're the ones who, without me having to prompt them, ask me, can I see you during your office hours? See, people don't see this, but this is what it's going to be like. There will be ups and downs, and it will be uncomfortable. Because there are times that you're going to be like, I made it this far and now I'm again down here, and it's going to frustrate you, and you're going to want to give up. And perhaps worse than that, you're going to want to settle. When things get a little tough and you're not quite at your goal, you're going to be like, well, I'm higher than I used to be. The goal is to get the chair from here to the end of the room. Here is not good enough. Here is not good enough. Here is not good enough. Get it to the end of the room at all costs. Because that's who I am. I am the person, when I set a goal, I get the goal. That's what success is. The people who are successful, the people you look up to, they're the ones who are going to do that. And they're the ones who are going to, when they're tired, when they could give up and be respectable, they push harder. Because like, I'm not hitting that 94. I don't care if you're impressed with me. I'm not impressed with myself. I set a goal for the 94. What I want you guys to be aware of, it's not going to be a comfortable path. So I want you guys to be aware, if you learn how to study, as I've been telling you, and even if you try to develop the mindset I've been telling you, there are times when you will hit snags in the road. It is inevitable. Life will throw these curveballs at you. That's just reality. You need to understand that no matter what, you keep pushing until you hit the mark. You do not give up before hitting that mark. I mean, you can relax when you hit the mark. You can be like, don't talk to me till the fall semester. I'm out. I'm going to Cancun for 3 months. I'm just gonna, do not talk to me. No one stress me out, nothing. Okay, you can give up at that point. Give up after you've hit the mark. But you know what? Something's special is going to, if you actually pull this off. A lot of you might think, well, yeah, I see what you're saying, but that's a high price to pay for pre-calc, isn't it? It's pre-calc, come on. Really, no one's going to judge me with a B plus versus an A minus in pre-calc. What you don't realize is that the price you pay continues to pay dividends. You see, now, you're not just some person who got an A in pre-calc. You're a different person with a new reality, with a bigger comfort zone. You are now on another level. Which means the next task you take on, you're going to start from higher. And now you'll be able to reach even higher than you did before. And now you're going to know the ropes. You're going to understand, okay, these things take a struggle. So if I have the ups and downs, I'm not going to worry about it. I just know eventually. And that's going to be what your Calc 1 is like. And then your Calc 2, you're going to be up here and even better. Calc 3 is probably going to be like, what the hell happened to math? Like, did math go on heroin or something? Right? But when that starts happening, you're going to be able to remember, oh, in pre-calc, I was pretty bad and I made it. Okay, let's go back to basics and let's start again. And you would come back and okay, all right, let's go over again. Right? What you're doing is you're building a part of your character. You're building a certain habit. You're building the habit that doesn't give up when it gets tough, but you push harder when it gets tough. Because that's what you're supposed to do. Kind of like when you want to solve an equation, say equal to 0 and solve for it. You're supposed to factor. You're not supposed to expand. In the same way, when you hit difficulties, you're supposed to push forward. You're not supposed to give up. That is moving in the opposite direction of your goal. You need to move towards the goal. Always move towards the goal. Always be on the offensive. Always be ready to push harder one more time. And once you become that new person, that is going to be your new reality. That's going to be like, some people are just, I don't really feel motivated. If you learn this, motivation will be a natural part of you. At least at that level, right? You'll need to learn to be motivated to reach even higher. But that's going to be like a natural thing. Like this is just how I do things now. right? Once you learn what you need to do in pre-calc, it's going to be like when you're in Calc 1. Well, that's just how I do things now. You know? And then you're going to be the person that everyone's looking at like, they're just a math person. They're not going to see where you were. But I want you to be fully aware, this is the journey. When you signed on to do what I asked you to do, it's not going to be a straight shot. These things are going to happen. I want you to know that they're going to happen. And I want you to know that when they do happen, you push harder. You don't push less, you push harder. You push towards the goal all the time. You do not give up before you hit the goal. Doesn't matter how hard it is, you have to pay the price. That's the price, right? Can't walk into a car dealership and looking at Lamborghinis. Oh, so how much is this one? $300. That's expensive. That's the price. You want a Lamborghini, that's the price. You pay that price or you don't get the car, right? That's just how it goes. Same thing. With success, it will have a price. It's not a comfortable price because necessarily to achieve success in something, you're going to have to be able to do something that you couldn't have done before. It's going to be uncomfortable. Guaranteed. So one thing there's a second side to this talk, and that is, if you think things are going great with your newfound way of life, you're probably not on track. In all likelihood, you're not on track. When you're struggling and you improve and then you drop, you take 2 steps forward, 1 step back, yeah, you're probably doing the right thing at that point, right? You should expect the discomfort. It's supposed to happen, right? Don't be afraid of it when it happens. Just understand that's the price for success, pushing through the discomfort. And I gave a few random silly examples here, but it could be anything. Things are going to come up that's going to try to steer you away from the goal. Tell you that it's okay, it's good enough, you can give up now. Or it's too hard, you're just not meant for this, you're just not cut out for this. Or whatever lie it's going to want to be able to tell you. Life can be very convincing in that way. And that's why most people aren't as successful as they want to be. Right? That's why we can have arguments about, the 99% versus the 1%. Because there are very few people that'll push through. A lot of people think that the people who are the high achievers, the people who are on top of their math class or on top of whatever, they're just born that way. Very rarely. Right? Look at the facts. I mean, facts don't really convince people, unfortunately. But you look at the facts. You actually look into it. Right? Anything that you have where you can say, oh, here's the group of people that are on top. Most of the time, they don't start there. And even if they start there, to stay there is hard work in and of itself. And that's just something you guys have to realize. So that's what I want to make sure you guys know. That even if you're putting into practice the kind of things I'm talking about, it's not going to be smooth sailing. You need to be vigilant. You need to always push towards the goal, no matter what. Don't settle for good enough. Settle when you hit the goal. And then from there, you can choose another goal. Something that was completely inconceivable before. I can tell you for sure, a lot of people think that I was always good at math. Go to little Javon and tell him, oh, you're actually going to be a college math teacher. I would have laughed in your face. Like, they want to stop me from taking science because my math sucks so much. What do you mean I'm going to be teaching in college? Wasn't on my radar. But in high school, they had tracks. You could do sciences, you could do business, you could do arts, or something else like home economics or something, whatever. I wanted to do science, my math sucked. So they told me, Javon, you can't do science. Give me a chance. I will prove to you that I'll be able to do science. That was my goal. That was my why. By the time I got there, I kept pushing so hard to the point where by the time I got to college, I'm like, being a math major is going to be pretty cool. I went from not being allowed to do science to be like, I'm going to do a math major. And that, so now I'm on another level where I couldn't even imagine. And it's not because I'm smart, it's just because, and it's not because I even knew this. Like, I wish someone knew this. Like, at the time, you know, it's kind of my father kept pushing me. He was the guy who kept pushing me up. Like you kind of don't have a choice where I was from. To be honest, that's what kept pushing me up the hill. You know, I mean, I'd fall down the hill. My parents would be like, you know, there was no such thing as child abuse where I was from. So it's like, you found your way back up the hill, right? It's not that I foresaw this. I just kind of fell into it. You know, but now I can tell you guys this is what it takes, and you guys are in the position where you have to push yourselves now. You're in college, you're adults. You're going to have to learn to push yourself. Set a goal, make it specific, give it a time limit, come up with a way to track your progress. Immediately come up with a plan once you find you're off course, and execute that plan. The faster the better. A good plan executed quickly is better than a perfect plan executed too late. Do something, do anything. Get advice so you can be more efficient. But that's what it's going to take. Now you guys need to be aware that's what it's going to take. I believe that's all I wanted to say.
I have a question.
Yes.
The next quiz is going to be on chapter 2.8 to 3.4, right?
I don't know. So our next quiz will have to be after spring break, because spring break starts this week. Right? Spring break starts on Friday.
Really?
So I'm not seeing you guys all of next week.
Basically April 30th.
So the next time I see you is going to be like April 30th. And I guess, I mean, at that point, I'd probably assume that you guys have forgotten everything. So I'll probably send out an email about what the quiz will be on. So a couple days before the quiz, I'll tell you. Oh, make sure you know this for the quiz when you guys get back.
No.
Come again? Friday spring break starts, I'm pretty sure, the 19th.
Friday.
Right.
Oh, yeah.
Yeah.
Every day is Good Friday.
That just made my day. That just made my day.
Okay, let's see what we can cover now. So, we're going to move on to 4.1. Talk about a very important kind of function, the exponential function. I'll probably have time to talk about 4.2, which is called the natural exponential. And mostly right now I want to set the stage. We'll probably do a lot more examples next time. But let's actually just talk about what an exponential function is and how it behaves. So the basic form of an exponential function is one that looks like y equals a raised to the x, where a is a constant. And we often assume that a is greater than 0, because assuming that a is less than 0 is problematic, and we know how to deal with it in certain specific instances, but for pre-calc, we only worry about it being greater than 0. We also assume that it's not 1, because if you have 1 to the x, then it's just y equals 1, which is a straight line. So we're assuming that it's some positive number not equal to 1, and that gives rise to another function, right? Now, you can start, so for example, y equals 2 to the x is an exponential function. Y equals 1/3 to the x is an exponential function. Which, by the way, we'll talk about this in a little bit, but you can also think of this guy as 3 to the minus x. We'll talk about the consequences of that pretty soon. You can also notice that this will be a reflection. We're going to talk about transformations. Okay, so all of these are exponential functions. Of course, you can have transformations of these. So you can have something like 3 times 2 to the x plus 1. You'd be able to look at functions like that. And you'll think of those as exponential functions as well. It just has a transformation. They'll behave just like a regular function. So that's the important thing. They are functions. They will behave how functions behave. So if you add a constant, it's going to shift it up, just like it would any other function. So all the rules that you know about functions do apply here. Okay? So these are called exponential functions. Now the graph of an exponential function is something that you should know. The graph of an exponential function will look like this. It starts very small, it gets smaller, but then it gets very big. So as you're going off there, you'll get closer and closer to 0. It'll never actually hit 0. So it's what we call asymptotic to the x-axis. But it will rise very fast. Exponential functions increase very fast, at least compared to any other function we've spoken about up until this point. So that's what y equals a to the x looks like. Not sure it might come up, but all exponential functions, all things that look like y equals a to the x under these conditions will have that exact shape. The difference is, of course, it can do transformations, but the steepness will change. So you can have something like, so it'll of course pass through 1, because when x is 0, you have a to the 0, which is 1. But what can happen is the steepness will change. So something like, you might have like 2 to the x's here, y equals 2 to the x. But it'll get steeper if you increase that, right? So this will be like y equals 3 to the x, right? So the bigger the number is, the steeper it will be. Okay, so that's an exponential function. They will always have that shape. Now, this more commonly happens in calculus because of, there's a rule called the power rule that students often apply to exponential functions when they shouldn't. So I want you guys to be aware that I'm describing this function, I'm drawing this picture, and it doesn't really do it justice. Exponential functions grow very fast. So I want you to look at there are functions that grow faster, and you'll kind of see this in future courses. For us in pre-calc, the exponential function is going to be the fastest growing function that we cover. So it's definitely faster than polynomials. And it's faster than logarithmic functions, which we'll talk about in 4.3. It grows faster than radical functions, etc. Everything we've talked about so far, this is going to be the fastest growing function. Now, me drawing this picture probably doesn't do it justice, so allow me to illustrate. So if you're looking at something like y equals x squared versus y equals 2 to the x. Okay? Now, if you were to sketch these on the same axes, normally students will go something like, okay, all right, so y equals x squared looks like this, you know. All right, that's y equals x squared. And then you'd have, okay, get another color here, maybe blue. And y equals 2 to the x would look like this. And that's y equals 2 to the x. And so you might get the impression that these two things are comparable. There's not much difference. You know, this is another case of the expectation versus reality kind of thing. Right? So people will kind of think, oh yeah, we can sketch both these functions in the same window. They're kind of Exponential functions has a weird shape, but nothing out of the ordinary. Okay, here's the reality. Let's say, and again, we're comparing, say, y equals x squared to y equals 2 to the x. And this is something you need to file away for calculus. It's going to be very important that you can understand this in calculus for a bunch of reasons. See, where the exponential function starts to differentiate itself. No pun in calculus intended. Is when you start looking out far, as x goes off to infinity. So we can imagine, okay, here's our exponential function doing its thing. Okay. That's the exponential function. That's y equals 2 to the x. What do you guys think x squared would look like on a very large scale compared to that blue line? Look like that? When you zoom out? Well, of course, that's to be expected. Here's what it actually looks like. When x gets big enough, an exponential grows so fast and becomes so larger, not only compared to x squared, but literally compared to any other polynomial. It could be x to the 1,000,000th power. Eventually you go out so far into infinity, the exponential is going to be way up here, and your polynomial might as well be 0. Might as well not even try. When I say the exponential grows very fast, I mean it. Like it goes, there is no comparison, right? You might be able to compare them down here, but once your x values start getting large enough, no comparison. Right? So if you're looking at, say, some weird function that's an algebraic function, let's say you're looking at something like x squared divided by 2 to the x, and then someone asks you, well, what would be the end behavior of that function? Right? As your x goes off to infinity, what would be happening here? Well, as x goes off to infinity, this guy's literally like 0. The end behavior would actually be 0. Right? So the top is going to infinity and the bottom is going to infinity, but this one is going to infinity so much faster, it's like that guy might as well not even try. Oh, you're squaring infinity? That's all you're doing? No. Take 2 to the base, raise infinity in the power. That's big, right? So that's one thing I want you guys to understand. This is why Einstein says compound interest is the 8th wonder of the world, which brings us to the topic of compound interest. Or maybe I should first talk about the transformations. So, note. Exponential functions. So again, I want you guys to know they can be transformed like any other function, and they are transformed in a pretty predictable way. So in that sense, they're not going to be different from any other function you know. So if you have something like y equals a to the x and you know the graph looks like this, then if you say y equals a to the minus x, meaning here you have your f of x and here you have f of minus x, that graph looks like, well, what would you do with any other function when you replace all x's with negative x? You flip in the y-axis. So that graph would look like this. And one thing is to note that one reason you can see why that happens besides the transformation rule is that this guy is really, by our laws of exponents, 1 over a to the x. So here I have 1, and the denominator is getting larger, the fraction is going to get smaller. And if you do something like y equals minus a to the x, that also behaves very predictably. That's just you taking this guy and flipping it in the x-axis. Right? So that will be true. And of course, like I said, adding a constant will shift it up, subtracting a constant will shift it down, multiplying it by a number in front will stretch or shrink it, just as normal. So you might look at something like y equals minus 8 or minus x. And so that's putting this guy upside down, it'll be that, etc. Right, so I just want you to be familiar with this new kind of function. Understand that it grows very fast, and your a is going to be a fixed constant. And while I don't want you to think in terms of plotting points, to give you some idea of how this function would work, you could plot points. Okay? So if you're looking at y equals, say, 2 to the x, right? When your x is 0, this guy will give you 1 because you plug in 2 to the 0. When x is 1, this guy's going to be 2 to the 1, which is 2. When your x is 2, this guy's going to be 2 to the 2, which is 4. 3, this is going to be 2 to the 3, which is 8, and so on and so forth, right? So you would plot, to get an understanding, when your x is 0, this guy is going to be 1. When your x is 1, this guy is going to be 2. When you go to x equals 2, this now jumps to 4, right? So it jumps by 1 unit here, it'll jump by 2 units there. When you jump to 3, it'll jump to 8. Right? It keeps jumping higher and higher per unit. So it's not like a straight line where there's a constant slope, where every time you move over this amount, you always go up by the same amount. The exponential function goes up by more the larger your x value is, and so it starts to plot. So a line would grow at a constant slope. This guy's being added by more. The slope is actually increasing as you move on. That's kind of what's happening. Now, a lot of you, some of you, sometimes people will tell you to do things, and because you don't have the mathematical awareness, it might not seem like a lot of sense to you. Like a lot of people will say, you know, don't save money under your mattress, don't save it in a savings account, invest your money. Because what happens is compound interest takes effect, and it turns out the compound interest formula, which I'm going to write down now, is an exponential formula. So you see, your money might grow like this in a savings account. It might even grow like that. If it's under your mattress, it's not going to grow any value. In fact, inflation is actually going to decrease it. And so you might not think, what is me investing $100 in the total stock market every month going to do? It's not anything. Eventually, right? It's not going to do anything today. It's not going to do anything tomorrow. 10 years down the road, 15 years down the road, you'd be surprised. Once that exponential function starts taking off, a lot of things in life are going to make a lot more sense to you when you understand there are other kinds of functions out there, and the difference in their behavior can be quite drastic. So, one important application is just that. Is compound interest. Now what compound interest is, it's when you invest money into an account, it gains interest, and then someone pays you interest on top of the interest, right? So the interest isn't only charged on the original amount that you deposit, it's charged on the interest that the money gains over time, right? So if you might invest $100, interest grows it to 120, then the next time they apply interest, they apply it to the 120, not to the original $100, right? So this accounts for something called compound interest. Basically, if you start with P, so this is your initial amount. Okay. Then after one cycle, you're going to have P plus some interest times P, right? So they're going to say, okay, we'll pay you 1% interest or whatever. You can represent that with a number. Okay, it's R times P or whatever. And that's going to be P times 1 plus R. Right? And so now what compound interest does is after 2 cycles, I'm not deriving the formula exactly, I just want to give you an idea. It will take that as the original money, right? So it'll put it down here, and then it's going to charge interest on that, the new amount, right? And what you'll realize here is that P times 1 plus R is a common term that you can factor out. And you would be left over with 1 plus R, because we are now great at factoring. So you'll end up with P times 1 plus R squared. And you can keep doing this, right? So after n cycles of applying interest, right? So after n cycles, your balance in the account is going to be, well, P times the original amount, 1 plus R raised to the nth power. Now this gives you an exponential function. This is going to be some constant raised to a variable, where n is counting the number of years the money was in the account. That gives you an exponential function, right? That's kind of what your money grows like when it's in the stock market, which gains like 7% interest, right? So you'd have the original amount of money you put in, and you could be even putting in more, and it will grow by 1 point, if we say 8%, 1.08 to the nth power. Eventually that starts looking like this. And for a while you might be investing your money, nothing's happening. Eventually though, right? Stop paying attention, set up an automatic deduction from your paycheck to go into that, forget about it. When you look at your account 10, 15 years down the road, oh, I forgot about that. Yeah, I wonder how much money I have. You would be amazed because it's an exponential function. So this is called compound interest, right? And the reason why it's so amazing is because most people imagine things growing like this, because from the day to day, that's how things feel like they're growing. But really, some things grow exponentially, and eventually they take off. They deviate so far from your expectations, it's not even funny. But this is compound interest. Now, they can decide how many times per year they want to apply the interest. And so sometimes they might say, okay, we're compounding it every 6 months, so you can put in the number of times it's being compounded times that. So that's like the general form. But, so maybe I should just write that down. General form for compound interest. At this point, I'm just giving it as an excuse to introduce something else. You don't need to know how to derive this formula or anything, so I'm not even being really technical here for compound interest. So this is a new formula that you should know. It says P of t, so this is a function of time. This is current balance after time t. I'll introduce the notation. So it'll be a function of time, right? So P is the current balance in your account after some time t. Usually it's measured in years. P naught will be the original amount invested, and it will grow like 1 plus r over n times nt. That's the original compound interest formula. N is the number of times it's compounded per year. So basically, every time someone checks into your account to apply the interest, they can choose when to do this throughout the course of the year. They can say, oh, we're only applying interest at the end of the year. Or they'll say, oh, we'll apply interest every 6 months, right? And your n would be 2 in that case. Oh, or we'll apply interest every 3 months, right? And then 4 would be your n, and so on and so forth. By the way, does anyone know how your credit card grows?
Pay it off on time.
Huh?
Pay it
No,
off.
how does interest compound on your credit card?
Late APR.
So when you put money into a savings account, those usually compound 1 time per year. At the end of the year, the bank looks at how much money and it applies interest. And then it'll do that at the end of next year. Credit cards compound every day, right? That gives you an exponential function. And that's why a lot of people get into credit card debt and didn't realize when it was happening, right? Right? That's how it happens, right? When you're applying interest, that's how people get into trouble. Because they're imagining that the debt is growing like this, when it's really growing like that. And eventually, before long, they realize, holy crap, I have like $10,000 in credit card debt. Where did that come from? The exponential function is where it came from. You need to be aware certain things in your life grow exponentially, right? And so having that awareness can help you make better decisions in and of itself. But this is a general compound interest formula. In this case, P of t is the current balance after time t. N is the number of times compounded per year. Basically, that means the number of times they are applying interest. R is the interest rate as a decimal. So they're saying it's growing by 5%. You put in 0.05 for R. And of course, T is time. Usually annual. Okay. So compound interest is a real world example that most people should know about because it controls more of your life than you realize. There are a lot of things in your life that you might not realize they're growing exponentially, and that should tell you how you want to make decisions about those things. So a lot of people would make poor decisions because of that. So for example, if they have a lot of credit card debt and they want to become more financially secure, they might focus on saving their money. But the thing is, it's usually a good idea to pay down the credit card debt first. Because you're saving money, and best case scenario, it's in the stock market growing at 8%. Credit cards often charge you interest rate like 20-something%. You're playing a losing game, right? And most people just don't realize that. They don't understand how incredible this function is, okay? That's for a topic for another time, probably. That's not the point of this discussion. I just wanted to throw it out there. So you should be aware, in a savings account, you don't get much interest and it's applied one time per year. On a credit card, they're charging a whole heap of interest applied every single day. Compounds at the end of every day. They're adding interest to your credit card debt 365 times a year. And interest on top of interest. And that's how people get in trouble and they don't even realize it. Everyone thinks, oh, you're in credit card debt, you must be very irresponsible. For some people, yeah, but for some people, there's normal everyday working people who don't understand what an exponential function does. You guys know better now, like I'm warning you. So I would read into this more, read into all that stuff. But I kind of will introduce this to introduce something else. So I'm not sure if the final asks you, if I see a problem on the final asking about interest, I might ask you a problem on it, but otherwise I don't think I'd really ask you a problem. This is really an excuse for me to introduce something else. See, the thing with math people is they usually don't care about real world application. They just like following the math. And so, a Swiss mathematician by the name of Euler considered a very peculiar case. All right, so now ask any math enthusiast, Swiss mathematician Euler. Okay, a lot of people pronounce his name as Youre. No, it's Swiss. It's pronounced Euler. You know, I always hear kids coming into tutor and say, "I need help with Euler's method." Euler's method. Okay, it's pronounced Euler, right? Half of success is sounding like you know what you're talking about. The other half you get by actually knowing what you're talking about, right? So you want to know how things are pronounced. It's pronounced Euler. Euler. Okay. Anyway, Euler. Anyone who's in the know, anyone who's a math enthusiast, anyone who's a mathematician, this guy is an example to us all, right? He was a mathematician who was very prolific even into his old age, which was very rare. Back in the day, mathematicians, if they made any great contributions to math, they did this at a very young age, and then they never really did anything noteworthy afterwards. This guy, into his old age, even after he started going blind, was crunching out theorems. There's so many things that he's responsible for, where if you get high enough in math and you're like, oh, use Euler's formula, the response is going to be, which one? Right? Which formula are you talking about? Use this, use that. Right? He's responsible for so many things that we're doing. It's not even funny. And talk about the greatest mathematicians of all time. He's definitely going to be in anyone's top 10, probably in anyone's top 5, anyone who's in the know. So, very important mathematician. He considered this scenario. Not a scenario that can ever be applied in reality. It's just a mathematical thought experiment, let's say. What if you started with $1, set the time limit for 1 year, and let's say whoever is collecting your debt is really mean, and they charge you 100% interest rate. But let's say they're even more evil than the credit card companies. They're literally going to charge you, they're going to compound the interest, not 365 times, not 1,000 times, not 1,000,000 times, an infinite number of times. Okay, so you have $1 growing by compound interest at 100% interest rate, and interest is just continually being added. Right? At every moment of time, interest is being applied to this thing. Now remember what we said happens with exponential functions. They grow super fast. It's amazing. Imagine with 100% and your number of times you're actually applying the interest goes off to infinity. Now the question is, at the end of the year, how much money would you owe? So now his question is, what is P after 1 year? Right? Now, you can never actually do this. It's a mathematical thought experiment. But the answer might be surprising to a lot of people. How much money do you think you owe?
Lifetime of debt.
Huh?
Lifetime of debt.
A lifetime of debt. Here's the answer. The balance after 1 year is actually going to be equal to, drum roll,
0.
well, it can't be 0, it's definitely growing. It's compounded. I'll write it in terms of dollars, so 2 decimal places. How much do you think? $10? $100? $1 million?
Billion, trillion.
An infinite amount? Yeah, probably. $2.72.
What?
That's all it would grow. In fact, the actual answer is a little bit longer. It's 2.71828.
Wow.
71828182849 and it actually repeats forever. It's a non-repeating decimal. In other words, in this number, no one has ever written it down in its entirety. It's kind of like pi. It doesn't repeat after a while. No one can predict all its digits. It's something that you figure out by just crunching more numbers. So that was a very special number to Euler, and this number is called, does anyone know?
Is it E?
E. This is called the number E. Why is it called E? Because Euler came up with it. So there's a number that we call E. This is a mathematical constant, kind of like pi. Whenever you're reading any mathematical literature and you see E in a formula, it's not like a letter, it's not a variable, it's a number, right? It's kind of like pi, it means something. It represents this number, 2.718. So this is a mathematical constant. kind of like pi. You know, whenever you see that symbol, it really means 3.1415. Right. So some people might know it from a circle, even though that's probably not the best way to look at it. But yeah, whenever you see this symbol, you understand, oh, it's representing some number. In the same way, the letter E from now on will represent a number. It represents this particular number. This is the number that 1 unit will grow to if you allow it to grow for 1 year under compound interest conditions with 100% interest rate, compounded more times than you can count. So it turns out that it doesn't go off to infinity, it goes off to this weird number. I don't remember how many digits Euler calculated it to, but it was a lot. This number in his honor is called E, the number E. Now, the number is, just like pi, it has a lot of mathematical curiosity about it, but what's more important about this number is the exponential function that it gives rise to. Now, when E is considered as the base of an exponential function, it gives rise to what we call the title of the next section, the natural exponential function. Now, it might be curious to you, why does this particular exponential function get a name? Do we call 2 to the x by a special name? No. So the natural exponential function is the function y equals e to the x. This is called the natural exponential function. And what is that number e? Well, it's this. So whenever you see that, e to the x, it's talking about a function, an exponential function. The base e is a constant. Now, why is it called the natural exponential? It's because in a lot of contexts, it is going to be the natural guy that you want to think in terms of, especially in calculus. They really got that name from calculus, right? You want to deal with an exponential function in calculus, this is the best exponential function to use. Now, the following statement I'm going to make, it's going to sound like an extreme overstatement. It's not, and a lot of renowned mathematicians would agree with me in the statement I'm about to say about this function. There is also, I don't know, if you have any math major friends, they'll hear about a textbook called Real and Complex Analysis by Rudin, is the guy's name. It's a very famous textbook because it's very dense to read. It's a very hard textbook, right? You have to fight. Every ounce of knowledge you get from it, you have to fight for it. But it's what we call elegant, right? He pretty much states things in the most concise way that they can be stated. And if you just read over it, you're not going to fully understand. But if you really try to understand it, right? So it's a very famous book, Real and Complex Analysis by Walter Rudin. It's a very high-level book. You need to take multivariable calculus and advanced calculus to be able to understand it. But in the prologue of that book, he talks about this function in the beginning. And the first sentence in that book is, this is the function, y equals e to the x, the most important function in all of mathematics. That is the first sentence in this book. And it is not an understatement or overstatement. This is the most important function in mathematics. Definitely in calculus. A lot of people would say the most important function in all of math. Like, all the wonders that you can get from this, I cannot be able to tell you from pre-calc. You'd have to go through Calc 1, 2, 3, Advanced Calculus 1, 2, 3, take a real analysis course, learn about series, and then you'll start to understand, holy crap, this guy is amazing. It's the most important function in all mathematics. It's called the natural exponential function. Now, as far as we're concerned in pre-calc, it's just another exponential function, right? It has the same graph. So if you look at y equals e to the x, just like any other exponential function, it's going to do that, passing through 1. So it's going to be, of course, somewhere between, so 2 to the x would be over here, and something like 3 to the x would be over here, so it's in between 2 to the x and 3 to the x. And you might think it's very curious, why is that number, why does that happen to be so important? But to understand the first remarkable thing about it, you kind of need to know calculus, so I can't really say anything more about that. But besides the zero function, this is the only function that is its own derivative. I'll leave it there. That's a very important thing. Okay, so this is called a natural exponential function. Now, like other exponential functions, it obeys all the exponential rules, that thing that from like lecture 1 or 2. So you have to know about that. It obeys all the exponential rules. So that means if I have two exponential functions, e to the x times e to the y, you get e to the x plus y, you add the powers, etc. Right? So all those rules that I gave you about exponentials, it will work here. It also works on any exponential function, and it behaves as expected under transformations. But it is an uber important function. I can say for sure you're not going to be able to appreciate why it's so important just from a pre-calc class, because you really need to understand it on a calculus level or higher to understand why it's such an important function. But it has a lot of nice properties that a lot of things about mathematics and about our universe at large can be stated in terms of this function. So we'll kind of stop there. I'm going to want to introduce the inverse of this function next time. That's another class of functions that we're going to want to talk about. And then we'll do some examples where we're kind of crunching some numbers, solving equations, graphing things, that sort of thing.